So the script first starts with the add health data. It pulls it in, it creates a network object out of it. In the StatNet frame, very similar to what we did yesterday, slightly different set of tools, but it gets you to the exact same piece. I then go through some StatNet layout features, right, using the basic StatNet plot function and show you how to color nodes and size nodes by that plot function. StatNet has a handful of plotting features. The one that's kind of interesting that you might not be aware of is that you can actually do interactive layouts with StatNet. So if you want to get in by your hand and move nodes around, you can do it and save it. It's a little clunky, but given the things under the hood, it's kind of impressive that Carter managed to pull it off. Then I'm going to abandon StatNet entirely and go to a couple of other packages that do some other interesting things that are just, frankly, just a little prettier. And then I'm going to end in the iGraph set, because the iGraph set has probably the widest array of different layout options. If you want to think about how these different layout options differ from each other, it's nice to have those there to play with. So that's what this script does. And it ends at the very end with one of these little drag around and make them bounce networks. Because why not? Because it's fun and it's dessert. So the first set of this, there's also a whole set of packages here that you might need to install if you want to do things with networks. There are lots of different tools out there for doing networks, including some for doing these network movies, which is this IndieTV package. I have them installed already, so I'm not going to install them again, but just so you know that I just put them all in one spot. I'm going to load up the data. In this case, I'm just pulling the data from the CSV file as opposed to the piece we constructed before. Let me scroll down so you can see that. All right. Then after I do that, I create the edge list. I look at it, and then I create an edge file from that, and then from that again, I finally go through and create the network. So this is with the first 76 lines of this program, just reading the data and create the network. Since we've done that in 3 or 4 other pieces today, or this week, I'm not going to go through it all again. You're going to see it's loading the packages, it's doing its thing, and it created the network, right? Now, I did my best to comment the code. Just like every writer has a style, every time you code something, you have a style. I drive my RA nuts by putting semicolons at the end of each line. You don't need a semicolon. I program in SAS. It just makes me feel like I'm at home. That's its only real purpose. And since it doesn't yell at me, it makes me feel happy, so I can have it. So I just pulled the first small network out of this fake add health data. All right, so it has 71 vertices. It's a directed network. It has 305 total edges, and we have that. For the most part, I try to comment the code out fairly well. What we're doing here, yesterday we did the set vertex attribute way of coding on an attribute in StatNet. This is the same thing with the %v coding. So I say on the graph object G, let's make an object called grade, which is taken from the add health school edge list or adjacency list data set, the variable grades. That's what this is doing. And I do it for a bunch of different kind of variables. Run that just to get those attributes. Again, we're setting a seed at the top. Setting a seed just means that if you use this seed, you'll get the same actual spatial layout that I do. If you don't, yours will be flipped or rotated or twisted or what have you. But it should be the same basic distance set. I'm not telling it anything else, right, other than to size it by the degree. Run it, and this is what you get. Well, this is not a bad layout, right? This is one of the things I want to point out, is that the default layouts of the Spring Embedded layouts for both iGraph and StatNet. For iGraph, the default layout is what's called Fruchterman-Reingold. Fruchterman-Reingold is the best analogy to that spring connection sort of idea that we've been talking about, in the sense that it cares not a nit about whether or not 2 nodes are on top of each other. It does nothing to stop node occlusion. And so if these 2 nodes are structurally equivalent, they will literally occupy the exact same XY space in the network, right? And so you might say, well, look, there's only 1 node there, and then if you've got a really big network, you can start moving that around and see that there are hundreds of nodes there if they all happen to be structurally equivalent. So that's in some cases that's a feature, in other cases that's a bug. The default in these sort of outcomes is to have lots of arrows and such. I'm not going to worry about that right now. You can change a lot of those features, both in size and color. In this case, I use the log of the degree as the size of the nodes, so that the bigger nodes have a higher degree, but it's not as big as it might be if you use just total degree. I don't know why I have these twice. Oh yeah, here we go. So now that was the jitter option. I'm sort of unstacked it a little bit, so I should be honest that in this case that I did tell it to do it a little bit. This interactive command, I'm just going to show you it just because it's kind of funky. If you run that, you'll see the plot looks exactly the same, except now it has this little thing there, select a node, a vertex to move, or click finish to end. And what you can literally do here is come and say, pick on a node, I click on that node, and then drag it somewhere else. And then it drags it to the side. Right? I click on this node, drag it up here. That's a pretty dramatic change. You wouldn't do that, right? I click on this node, drag it way over here. And so, but it does get, just want to point out that if you want to get in and all you want to do is just adjust a little bit on the edges where one node is or not, it's not a bad way to get in and do that. When you're happy with where things are, you click finished, and then there you have your plot. The one thing to keep in mind is that I tend to go to futz with things a lot by hand. That's why I use another program, and it saves each step of the ones you were playing with all the way through. So if you're going to do like hundreds of these moves, you're going to build this little file full of hundreds of pieces there, just so you know you have them. So I tend not to use StatNet much for my or R much for my visualizations, but when I do, it's not like a bad advertisement. I use iGraph or some of these other tools. The ggplot and ggnet programs are ones I like. This is a really nice. A lot of GitHub sort of pages are pretty crappy, but this is actually a really nice web page that they've set up to describe what this tool can do. So if you really want to play with it, I would go there. But I just want to give you a sense of what these graphs look like. The idea is to build on the ggplot sort of graphing framework, which is all about building layers. So you start with the most basic things and you layer on information in a very deliberate way. So the most basic sort of bare bones network that you would get from a ggplot is awful, right? Like this is like it's there, but there's no information on top of it. But what's fun is that you can literally add all kinds of different information, right? So I can set the node size, I can set the arrow size, I can set the distance between the arrow and the node, so this gap, right? So if you go into the help for this, which we jumped over at the time, there are literally hundreds of parameters you can set to fine-tune the elements of this visualization. So in this case, you get that. Right, so in this case, I've used one of the palettes that are supposed to be easier to compare and colorblind friendly and such. And so that's what I've done in that case. I've set a transparency so the nodes are on top of each other. You can kind of see when they overlap. It automatically gives me a key for the grade. I've suppressed the key for the size. So it says I've sized the nodes, but I said don't give me that guide. And so you can get a nice sense then of what, that's a nice way to see what's there just quickly. And again, there are lots and lots of opportunities with this package. If you want to play with some of the other fun things, you can play with this Network 3D program, or Network D3 program, sorry. It'll take a second for this one to run. I just ran help. Oh, where are we going? There we go. Skipped over it, sorry. There we go. So this is one of these interactive pieces, right? So this is the simplest version that has no other elements. And the nice thing about the simple version is that it'll take a network object. But again, you can just get in and play with it all you want. Waste an afternoon. Why not? But if you want to do that same kind of thing with a little bit more actual information embedded on the graph, it won't take a graph object. You have to change it into some data frames. And so you go through and do that again and run it. Now you get the same thing, but now we've retained grade as the coloring. We have some other information in terms of edge size and so forth. But you can get in and really stretch things around. Because it's a force embedded, because it's essentially a rubber band network, it's always going to spring back to roughly the same shape. But if you want to get a good intuitive feel of what these networks are doing, that's really or these layouts are doing, that's the main reason to use this. And again, I'm already over time, so I'm just going to go through and say, detach this package real fast. There's some code in there to send that to a web page if you want. I'm going to detach that package. And then go into iGraph. The vast majority of the work that I do in plotting in R is in iGraph. The basic default plot in iGraph is the worst of the bunch. It's sort of got these big arrows, and it often has things clustered on top of each other. But once you get the syntax down, as you'll see in the piece here, there are a whole series of things you can do to describe the different pieces of the vertex, or the color that I'm going to do, the label I'm going to do. I can change size, right, whatever else. And again, I won't go through all the pieces, except that I have to do that if I'm going to make this run. Oh, I'm trying to do things too fast. There we go. So then you get, in this case, this is the walk trap community detection that I picked just out of the air. But again, there's a bunch of these you can do. One of the nice things about iGraph is that it comes with a lot of different layout options. So here, if I wanted to, instead of using a spring embedder, I wanted to use a multidimensional scaling layout, I can just go like that. And then you get a distance now. This is a metric space as opposed to this crazy spring embedder space. And if that's something that floats your boat, you can use that. There are about 30 different layout pieces that you can use in iGraph, and about down here at the end, you can see what those are, right? So you can see that there are lots of different layout options here. My favorite, just from a naming standpoint, is layout nicely. I'm not sure why you'd ever want layout bad. So layout nicely, that's in there. That's just a slightly little bit of fuzz on top of the Fruchterman Rheingold. If you don't know what else to do, right, and you're saying, come on, Moody, just give me one sort of bit of information on what to do, your single best choice is usually Fruchterman Rheingold, which is layout with Fruchterman Rheingold, right? If you're worried about lots of clumping, the second best thing to do is layout with KK, which is Kamada Kawai. Kamada Kawai is a distance-based layout. It's trying to get at something very similar to an MDS, but it puts a bit more repulsion on the nodes across each other and gives it a little more uniform layout. So again, I'm going to leave that to the homework for you to go through and find this stuff. There's a bunch of these in here. I was more ambitious, obviously. And just in the interest of time, for fun, I'm going to show you this. So the Viz Network tool is another one of these spring embedder kind of layouts that are interactive, but it allows you to put lots of different information on top of the network. So in this case, it's a little bit slow. There we go. Is that it? That's not it. That's the one we had a minute ago. Well, now it's not going to work. There we are. Okay. So what's nice about the Viz Network one is you can color really nicely by different colors, but it also has a really nice zoom feature, so you can get in there and sort of look at things. But again, it's just like the others in the sense that it lets you go in and do that kind of stuff. In the script, you'll see code for writing these out to web pages if you want to make it interactive and directly. There's also another nice tool, a whole suite of tools that work with JavaScript, so these .js files that can be used to embed a database behind the network. So if you want to build one of these exploratory graphs, you can do that. But otherwise, we're already well over time. I think I'll stop there. Other questions or thoughts?
Is the fisheye thing something you've done in like R? Or?
I've never been able to get that to work in R. I'll be honest, I haven't looked very hard for it in R. Payek and Gephi do it just as a matter of course. You can just literally hover over a node and change it all you want. If anybody wants to play with Payek or Gephi at some point this week, grab me and maybe we can do a little breakout for it. Payek takes a fair amount of patience to get used to using in the way that it does. but if you once you get there, like any of these packages, once you get there, it can be quite useful. Gephi is a lot easier to use out of the gate, especially if you have a Mac, but it tends to be really hard to install otherwise. Once you can get it working, it can be quite effective. Any other questions? You're going to be bored stiff of me tomorrow, so you get me literally all day. So I'm loath to keep you here much longer than this. Any other announcements, Molly? All right, thanks, folks. We'll see you tomorrow. Have a good night.